In the previous videos, we started working with objects and classes. It's now time to talk about inheritance, what that is, and how it applies to objects. What is inheritance and why is it so powerful? We can look at inheritance as a form of code reuse. It's a way to organise classes into a parent-child hierarchy which lets the child inherit, in other words reuse, fields and methods from its parent. The animal kingdom, with its many classifications, is a pretty good place to start looking at hierarchical relationships. On this slide we show a small part of the animal classification chart. Each box on this diagram represents a class. The most generic or base class starts at the top of the hierarchy. Every class below it is a subclass. So animal is the base class. All the other classes can be said to be subclasses of animal. A parent can have multiple children, as we see with mammal, which is the parent of dog and cat. A child can only have one direct parent in Java, but it will inherit from its parent class's parent and so on. Let's actually start working through some scenarios in code so that I can show you what inheritance looks like in Java. I've created a project called Inheritance and created the main class and main method. First, let's start with an animal example. I'll create the animal base class and define all the attributes and behaviours that animals have in common. We know that any animal would have characteristics such as size and weight. We also know an animals move and make noise. Though animals move and make noise in very unique ways, I declare the methods on the base class. Let's see what this class might look like on a class diagram. This is just a drawing of the class showing its fields first and methods or behaviours in the section below that. A class diagram allows us to design our classes before we build them. This diagram shows the animal class with the attributes I think that every kind of animal has. All animals have a type, what kind of animal it is. All animals have a size and a weight. Below the fields I have the behaviour that animals have in common, move and make noise. The move method will include a speed, fast or slow, as an argument. Let's create this animal class now. From the SRC folder, I'll right-click and choose New, then Java class, and name the class Animal. After I have the class in the editor, I'll add the fields from my diagram. String type, string size, double weight. Okay, those are the fields. Let's add a constructor. I'll use IntelliJ's code generation tool to do this. I'll put my cursor below the last field, select code on the menu, then generate and then constructor. I will select all the fields and hit OK. Now I've got my first constructor, as you can see on lines 7 through 11. Let's keep this code simple, so I'll leave the getters and setters out, but I do want a method to print the fields out, so again, using IntelliJ's generation tool, I'll pick code, generate, and this time I'll select toString, and again pick all the fields and hit OK. And there's my toString method with all the fields in it. Okay, so I have attributes, a constructor, and a way to print out information about the animal, but I haven't implemented any behaviour on animal. I'll add the two methods on animal to achieve this, namely move and make noise. For move, I'll take a speed which will just be a string for fast or slow, and then I'll print the animal type and the speed at which it's moving. The move method will be void, and as mentioned, I'll make it have a parameter called speed, which is a string. I'll print the animal type and how it moves. I'll add make noise that doesn't have any parameters. I'll indicate that this animal makes noise. There you have it. I have my base class, the animal, with its attributes, type, size and weight. And I have three methods on this class, toString, move and make noise. Next I want to create a more specific type of animal, and for this I'm going to create a dog class. Let's look at a class diagram that includes the dog class. Here is the dog class connected to animal. This means dog inherits from animal. I can also say dog is a type of animal. When I create a dog object, it'll inherit the type, size and weight fields from the animal class. These don't have to be explicitly declared in dog. This is also true for the methods move and make noise. I can specialise the dog class with its own fields and behaviour. I do this here with ear shape and tail shape because dogs have ears and tails whose shape are unique to their breeds. I'm also add that dogs have behaviours like bark, run, walk and wag tail. How do I build this in Java and make dog inherit from animal? Let's create a dog class first. To specify I want this class to inherit from animal, I use another Java keyword, extends. Using extends specifies the superclass or the parent class of the class we're declaring. I can say dog is a subclass or child class of animal. I can say animal is a parent or superclass of dog. A class can specify one and only one class in its extends clause. I'll add that clause to my dog class. It goes right after the class name and before the opening curly brace. Extends animal. Now you notice straight away that I've got an error. The error that's on the screen is saying there is no default constructor available in the animal class. And that's true, I didn't create a constructor with no arguments on animal, but why does this matter to the dog class? Well, right now I haven't declared any constructor for dog, but maybe you'll remember that Java will declare a default constructor implicitly if we don't explicitly declare one. But because we did created that 2-parameter constructor, the default constructor was not created automatically by Java, and just to see that, let's add a constructor to dog, which mirrors the implicit constructor Java creates for us if we don't manually create another constructor. Public dog and parentheses. I'll add super and parentheses. This is what the implicit constructor looks like, and now the error is on line 4. The reason it isn't working is that statement on line 4, super parentheses. Okay, so maybe you're asking the question, what's super parentheses? You'll remember I used the keyword this followed by parentheses and parameters as a way to call another constructor in the same class. Well, super parentheses is similar to that. It's a way to call the constructor on the parent class or superclass. Here I'm calling animals constructor by using the keyword super and then parentheses, which calls the default constructor on animal. Super with parentheses is a lot like this with parentheses. It's a way to call a constructor on the superclass directly from the subclass's constructor. Like this, it has to be the first statement of the constructor. Because of that rule, this and super can never be called from the same constructor. If you don't make a call to super, then Java makes it for you using super's default constructor. If your superclass doesn't have a default constructor, then you must explicitly call super in all of your constructors, passing the right arguments to that constructor. Those are a lot of rules, but don't worry if that's confusing right now. We'll be reviewing these rules coming up and in future videos. For now I have a compiler error on dog because animal doesn't have a default or no arguments constructor declared for it. Let's go back to animal and add that in. Public animal, parentheses. And now I've got everything compiling, so that's a good thing. Before I do anything else with dog, let's go back to the main class. Before I create any instances, I want to create a method on the main class that will take any animal object and execute its 3 methods. I'll call it doAnimalStuff and pass it an animal object, and the speed I want this animal to move, and then I'll have animal make noise, move, and then I'll print out all the attributes on animal. I'll use static and void, and as parameters I'll define animal and speed like this. Let's make the animal do something. I'll call animal.makeNoise, then call animal.move, and I'll pass speed as the argument. I'll print out animal here, and print out some underscores. This method is static because I want to call it from the main method. The last line is just to separate the data, so reading the output is easier. Let's create an instance of animal first, and then pass that to this method. Animal, animal equals new animal, and as arguments I'll pass the literal strings generic animal and huge, then 400. Invoke doAnimalStuff, passing our animal object, and the literal string slow. I created an animal object, gave it the type generic animal and the size huge, as well as a weight of 400. And running that, I get generic animal makes some kind of noise and generic animal moves slow. And then I get the data from my toString method, which prints out all the attributes starting with the class name of the object. Okay, so that's a generic animal. Let's create a dog this time. Dog equals new dog and parentheses. Invoke doAnimalStuff, passing the dog object and the literal string fast. Before I run this, do you notice what I'm doing here? I'm passing a dog object as the method argument when the type was declared as an animal. Why is this okay? It works because dog inherits from animal. It's a type of animal, as I've said, and where that becomes really important is in code like this. I can pass a dog instance to any method that takes an animal, and running that. The code compiles and runs, and I get output, null makes some kind of noise, and null moves fast. I created a dog with a default constructor, no arguments passed, so nothing got set on this class, but you can see dog has inherited all of animal's attributes on that last line. The values have the default values for their type because I didn't create a way to pass any data to these fields on dog. So far all I've done with dog is extend animal. Next let's change my default constructor in dog, and this time when I call super, I'll pass values to animal's 3-parameter constructor. I'll pass the type of dog, which here I'll call it a mutt, then the size big and 50 for the weight. Super, and then those 3 arguments. And I can rerun my main method. And now the output has my mutt's attributes, so it prints out that mutt makes some kind of noise, mutt moves fast, and then it shows the other attributes on mutt. What I want you to see here is, look at the dog class. It's 6 lines of code including the opening and closing braces and white space. But this code can now execute 3 methods and has 3 attributes I can set, all inherited from animal. And better yet, I can treat this dog like any animal for any code that uses the animal class. My doAnimalStuff method in the main class didn't have to change at all even though I introduced a new class. Up until this point, I haven't specialized anything for the dog. Since this video is getting long, let's end it here. In the next video, I'll add the fields and methods that make the dog class unique. I'll see you in that next video.